But hopefully for tonight is solve, graph, check, and write the solutions and set notation for those problems. And so make sure you work on numbers 1 through 5. I'm going to go over those today. Also the graphing portion for 6, 7, and 8. I'm going to go over that today also so you can refresh in your noodle. But hopefully everything that we've been reviewing so far, it's ringing a bell. Is that correct? It's coming back little by little? All right. And we'll get started on our lesson. Just copy that, please. I'll give you a little bit more time. All right, so if you guys notice, we're still finishing up our Algebra 1 concepts before we get started with our Algebra 2. So today we're going to be looking at inequalities. Inequalities, your favorite. Yay. So really quick, writing utensils down, look up to the screen. Here we go. I'm going to go over the introduction really quick, as I always do every year, but so that you guys are on the same track in regards to where we get inequalities. Last week we introduced one variable equations. We said that they come from balance scales because we need to balance each side. That's why we do the same thing to both sides. However, it's equal. Is that correct? Yes. All right. So what if I put weight on one of these sides of the scale? What happens? It'll go down. So like that. So check this out. So what's on this side? 8 pounds. So I write 8. What's on this side? 0. So question. Where was the bar originally? Up here, wasn't it? It was balanced right there. What do you see now? It's unbalanced, and look at the inequality that it forms. Yes? Okay? Same thing if I was to balance it out, once again, to make it an equation, I balance it out, so it will be 8 equal 8. Are we there so far? So what if I add more weight now to the right side? If I add more weight to the right side, it drops, and it works the same way. This is 8. This is 11. The original bar was about right there, so therefore it goes that way. Does everybody see the arrow? Yes? Turn to your neighbor, let them know where the arrow is at so that they can see where I'm getting that from. Some people are looking at me like they don't see it. We good? All right. So, once again, what are equations? Equal. What are inequalities? Not equal. Equations equal inequalities. Okay, some of you are a little bit distracted. I'm saying it's going to go escalate pretty quick and you're not paying attention. Here we go. Equations equal inequalities. Not equal. Okay, now that we got that, let's get started. I can solve and graph one variable inequalities. Once again, I can solve and graph one variable inequalities. Take a neighbor the concept that we're on now. One variable inequalities, and that goes in your Freire model. It goes in your Freire model. It looks something like this. Okay? All right. Now, I'm going to help you fill that in, but by now, you should be able to fill it in by yourself. I'm just going to help your noodle a little bit. Here it goes. Okay? So, we're going to write a definition, but before we do, you're going to come up with a definition. Ready? Here it goes. Writing utensils down. Look at me. Here it goes. Ready? Here it goes. So, last week, we covered one variable equations, and we finished with that yesterday. Just think about the definition. Don't say it out loud. The definition for one variable equations, we're thinking about it. We're not looking in our notes. The definition for one variable equations. Tell your neighbor, please. One variable equation. All right. Let's see. Kenzie, go. One variable equations. Does everybody agree with that? Two expressions equal to each other, one unknown variable. With that said, and with the introduction that I gave you for inequalities, look at the Freire model. One variable inequality. Think about the definition. Tell your neighbor. Write it in there, please. So I heard, let's see. Did I hear two expressions what? Not equal to each other and containing one unknown variable. That is correct. Write that in there, please. Damn, you guys are pretty good. Remind me of me in kindergarten. All right, examples. I'm going to show you some examples here. Copy those. And as soon as you're done, I'll go over that really quick. Copy that. All right, here we go. According to the definition, let's see. It says two expressions equal to each other and contain one unknown variable. Let's see. X plus 2 is an expression, 25 is an expression, and they are not equal to each other, and they contain only one variable. Yes? 12 is an expression, y minus 8 is an expression, they're not equal to each other, and only one variable. Okay, bless you. Same and same. The only thing these have different is that they have or equal to, but we'll talk about those in a little bit. But they all have inequality symbols. Okay, let me show you some more examples. Don't copy these. Now let me show you the non-examples. Copy those. As you're copying the non-examples, start thinking, why are these not one variable inequalities? Copy those, please. All right, let's see. Start with this one. Ethan, why is this not a one variable inequality? It's an expression, that is correct. It doesn't have any equal or inequality symbols. Pass it to someone. Josh, why is this one not a one variable inequality? So what is this called? One variable equation. All right, pass someone. Has an exponent. And when we get to these, once again, I said we first solve for y, and then it becomes a two variable equation. Pass someone. Ramon, why is this one not a one variable inequality? So what is this one called? Two variable inequality. We will get there, but for right now, let's go. So with that said, get some hashtags here as to what makes one variable inequality one variable inequality. Corina, go. No equal sign. Pass someone, Karina. Jake. One variable. Pass someone. Jordan. Inequality. Woo! And so on and so forth, right? All right. So now that we got that out of the way, really quick, these are the steps we're going to use for solving inequalities. Tell your neighbor what you noticed from these to what we did last week. The same process for equations applies to inequalities. Let's go. There's only a couple of things that we need to look at when we solve inequalities, and we're going to go over that in a little bit. But overall, the whole process is the same. Is that correct? So step one, simplify. Second step, isolate, plot, and check. We got it, right? All right. So, no. So, really quick, I just want to introduce the signs in case you you didn't remember them. This one is less than. This one is greater than. This one is less than or equal to. This one is greater than or equal to. And the last one is not equal to. These are the inequality symbols. Students, inequality symbols, students. And also at the end of each problem from this point forward, we're going to use set notation. Yay, our favorite. You guys remember those? And of course, I'm going to show you once again, refreshing your memory as to how to write them. They are. Here we go. So, right now what I'm going to do, I'm going to start off with the first graph. So let me do some techie stuff here in a second.
What?
Let's go. All right, writing utensils down, look up to the screen. Here it goes. Focus, please. Especially those of you that did not go through this with me, you might have another interpretation of it, which is fine, but I just want you to understand what we're looking at. Okay? Here we go. First, do you notice we have a number line here? Second, do you notice that on top of the number line, there's a graph graphed on the number line in red? Yes? And where does it start? At 5. And it continues going. That's what the arrow indicates, that it doesn't stop. Focus, please. Where it begins, we have a name for it. It's called dividing point. And why is it a dividing point? Because it divides the number line into two sections. The section where the graph is at, that's what we call the solutions. The section that we don't have anything of the graph is called non-solutions. Are we there so far? All right, let me refresh in your memory as to how to write an inequality from a graph. Here it goes. First, we need a variable. I'm going to use x. Next, we need the dividing point. What's my dividing point? 5. Okay, to find out which direction the arrow points, we need to check a point or test. So, which number do you want to use from the solution set? All right, let's use 0. So, 0 instead of x, and I bring down the 5. Question, which one of these, if they were on the scale, is heavier? 5. That means this side will drop. Is that correct? And that means the arrow is going to point that way. Now, I don't write the equal sign on it because this is an open point. Everybody see that? All right, copy this. This is example Q. For right now, it's open because that's the graph that it gave us. Yeah, I'll show you when we graph how to graph the point where they're open or closed. Okay? Copy that, please. All right, so this is the first graph. Once again, any questions on what we have on the graph? We have the number line, we have a graph, we have a dividing point, we have the solution section, and the non-solution section. We wrote an inequality from the graph using a variable and the dividing point, and then we just tested a point from the solution part, and that's how we know where to point the arrow. Okay? So I'm going to go back to the table. Pay attention, please. You're going to help me with this one. So we said x and 5 is our dividing point, and we said it was pointing that way, yes? All right, here we go. I need to write another inequality for this one. So what do I need? A variable, x, and what is my dividing point? -1. Okay, there it is. All right. So now, I have this inequality. I need to test a point from here from the solution set. It could be a decimal. It could be a fraction. Some of you said 1. I like to use 0. Yes? So I'm going to use 0. 0 and -1. Now look at the number line here. 0 and -1 are right here. Don't we say that all the numbers to the right are usually greater than the ones on the left? Yeah. So therefore, out of these two, which one is greater? 0. That means this side is going to drop. Is that correct? So if this side drops, this one doesn't, that means it's going to point that way. Yes. Yes, it does. We always use where it begins, the graph begins. This one began at what? 5, and this one begins at -1. Oh, you mean the test? Yeah. No, it doesn't matter which number you use. As long as you use a number that's on the solution, so like that, you can confirm. Okay? All right, let's write one for this one. We got x and what? 1/2. Okay. What number do you want to use to test? 0. Is 0 and 1/2. Which one is heavier? So this one drops. This one stays the same, so it goes that way. However, do you notice this point is a solid point? Focus here. So we put in equal sign. Okay? Yeah. All right. So I want you to write on your paper an inequality for this graph. Ready? Go. That's example super Q. Example super Q. Write me an inequality for this graph. Go. Once again, we start with a variable. What's the dividing point, everyone? 0. What number do you want to test from this? We can't test 0 because we already have 0. 1. So I'm going to use 1 and 0. Which one is greater? 1. So that means this side drops, this side drops, this side stays the same. It goes that way. Is it a solid point? Yeah, so we put a little equal sign in it. And that's how you write your inequality. So that's going to be for 3 other problems on your home quiz. Let's crank it up a notch, yeah? Yeah. Here we go. Here we go. Copy this one. Example 1. Focus, please. Copy that, and I'll go over it. All right, here we go. So really quick, we solved it. We end up with an equation, and what did we see? That it flips the inequality symbol when we divide or multiply by a negative. So we wrote our note. So graph, we start with our dividing point. It's a solid point because it has an equal sign, and we tested 0. Let's see, let's read it. Substitute in 0 in here. Is 0 less than negative 1? No. Did it work this way? No. So what does that tell us? That half is no solution. So which direction am I going? We're going in that direction. And lastly, let's write our solution set. Solution set of all x's, because that's the variable that we solved for, such that, what did we end up with at the end? X is less than or equal to negative 1. Does it come back, yes? Okay? Yeah. I try not to go with that so that you guys can understand. Hold on. Lastly, look up. Look at this one. If I was asked to solve that, what would be the first step? Multiply times 4, right? Or if I give you this easy one, simplify each side, and then at the end just solve for the variable, yeah? All right, so your home play for tonight, you already have it. Enjoy your home play. Have somebody in your logo put away the iPads. Enjoy your home with you guys. Molly.